So this video covers the final section of Module 8, which is Module 8, Part 6, Quadratic and Form. Please make sure you're completing your guided notes as we go along. So quadratic and form is something we've actually seen before. I touched on this very briefly in Module 5. And what that is that's a non-quadratic equation that can look like a quadratic equation if I write it a certain way. So for example, if I've got AU squared plus BU plus C is 0 and use an algebraic expression, then this is quadratic in form. So what example might that be? Well, let's say I had x to the fourth minus x squared minus 6 is 0. This is something that's quadratic in form because I could rewrite it as x squared squared minus x squared minus 6 is 0. And then we could let u be x squared, and I can still solve this equation. We let u be a temporary variable that's standing in for that algebraic expression. Other examples could be something like if I've got x plus 5 squared minus x plus 5 minus 6. In this case, this x plus 5 would be our u. And we could do u substitution to plug in u instead of x plus 5, and we could see how we'd need to factor that. So let's practice defining our substitution variable. So let's define u in terms of x and write each equation as AU squared plus BU plus C. So here in example 1, I've got 2x to the fourth plus 5x squared minus 12. Well, here our u would be x squared. So I could rewrite this as 2u squared plus 5u minus 12 is 0. Again, I'm substituting u in for x squared. Now that this looks like a quadratic, I could factor it, solve for u, and then plug my x squared back in to eventually solve for x. And that's what we're building up to. In problem 2, let's let u be x plus 5. So I've got 3u squared minus 7u minus 6 is 0. This is how I would rewrite it. So how do I solve an equation in quadratic that's quadratic in form? So the first thing is something we've already practiced. We have to define that temporary variable u and substitute u into our original equation. Then we need to solve the quadratic equation that we found in step 1. For u, we're going to solve it for u. And we can do that by factoring, completing the square, or using the quadratic formula. I prefer factoring, completing the square. I know a lot of people love the quadratic formula because it always works. So luckily for you, any of those methods will work. Next, once I solve my quadratic, I'm going to replace our u with the expression we used to define it in step 1. And then I can solve the equation for our x's. And we have to check all solutions by substituting them back into the original equation and writing our solution set. And it could be the case that we have more than our standard 2 solutions. So let's work through 2 examples. So here I have x squared minus 4x equals negative 2. So I'm going to first move this negative 2 over to the other side. So I have x squared minus 4x squared plus 2 is 0. And I'm going to let u be x squared. So I'm going to have u squared minus 4u plus 2 is 0. And then I need to solve this. Well, I can't factor it. There are no factors of 2 that add up to negative 4. So I'm going to go ahead and solve this by completing the square because I prefer that to the quadratic formula, but you could use the quadratic formula. So let me go ahead and move that 2 back over. I guess I could have left it over there. And I'm going to add my b divided by 2 squared to both sides, and because that's what we do to complete the square. Let me label it so you know which method I'm using. So I'm going to have u squared minus 4u plus 4, because negative 2 divided by 2 is negative 2. Squared gives me 4. It's negative 2 plus 4. So I've got u squared this left-hand side, it's going to factor to u minus 2 squared, and my right-hand side simplifies to 2. So I go ahead and take the square root of both sides. So I get u minus 2 is plus or minus the square root of 2. So I'm going to get that u is 2 plus or minus the square root of 2. Now I substitute this back in for my x squared. So I've got that x squared is 2 plus or minus the square root of 2. And so I've got to take the square root again. So I have x is plus or minus the square root of 2 plus or minus root 2, which is a very ugly answer. But works. If you plug it into your calculator, you're going to get multiple. You should get a real value, an irrational value. What's important to note is I've got x's plus the square root of 2 plus root 2 plus the square root 2 minus root 2 minus the square root of 2 plus root 2 minus the square root of 2 minus root 2. I'm going to have 4 possible answers. For our next example, I have 5 times x plus 3 squared plus 9 times x plus 3 equals 2. And I'm going to let x plus 3 equal u. So I've got 5u squared plus 9u, because my u is x plus 3, minus 2 is 0, because I went ahead and moved this 2 over. So now I have to think, okay, are there any factors of AC, which is negative 10, that add up to B, which is 9? Yeah, how about 10 times negative 1? So I've got 5u squared minus u plus 10u minus 2 is 0, and now I can factor by grouping. I've got u times 5u minus 1 plus 2 times 5u minus 1 equals 0. I collect my greatest common factors and what they left behind. So I have u plus 2 is 0, so u is negative 2, and 5u minus 1 is 0, so 5u is 1, u is 1/5. I then can go ahead and substitute in my x plus 3 for u. So I have x plus 3 is negative 2, so x is actually negative 5. And I have x plus 3 is 1/5, so x is negative 15 thirds plus 1/5. I'd have negative 14 thirds. Those would be my two x values.